In this video, we're going to be looking at equations of circles, and we're going to start with what's called the standard form. And the standard form of a circle looks like this. It's not going to work. In this video, we're going to be looking at equations of circles. There's two different forms of equations that we're going to learn. The first in this video is going to focus on standard form. And standard form looks like this. That's h right here. So we got x minus h squared. We're going to have y minus k squared. And that's always going to equal whatever the radius is squared. And sometimes you may forget that it equals r squared, and you may write your equations with just r here. So really focus right here. The standard form is always equal to r squared. Alright, so what does that look like? Well, let me get a graph going here. If I draw a nice little circle, let's see. It's pretty good. So right here, the center of my circle seems to be right here at the origin at 0, 0. And that happens to be what h and k represent. So in this standard form, h is always going to be the x value of my center, and k is always going to be the y value of the center coordinate. Be careful though. When you write your center coordinates, it will appear to be the opposite of what it looks like in your parentheses here. So a value of 2, let's just say that I had 2, 3, for example. That was the center of my circle. In my equation, it would look like x minus 2. And it would look like y minus 3 there. But if I had something like negative 2, then in my equation it would appear to be positive, because minus a negative, a double negative will become positive. Now if that doesn't make any sense, we'll do an example and I'll try and reinforce that. But in this example, our center is not at 2, 3. What is the center of our circle here? The center of this circle happens at the origin 0, 0. So if I were you, anytime you're dealing with circles, I would always just come up with your center coordinates just so you can always double check yourself. So 0, 0, that's where the center is. And r, if you are looking at a graph, you can always count it. Remember, the radius is always the distance from the center of your circle out to the outside of your circle. So you can count it if it's graphed. We got 1, 2, 3. So our radius will be equal to 3. So let's write the equation of that circle. Just substitute everything we have here. X minus h. Well, h is right here. K is right here. So just substitute those two values. So we got x minus 0 squared. Then we have y minus 0, because the value of k is also 0. And it's equal to 3 squared. All you got to do is simplify. A lot of times you'll see equations of circles with centers at the origin written without the zeros. So because we're subtracting 0 here, that doesn't make much of a difference. So we just rewrite it as x squared. Same thing with our y. Oops, we forgot the squared there, sorry. Since it's subtracting 0, it's not necessary. We just write y squared. You will see a circle, the equation of a circle, written this way if the center is at the origin 0, 0. And then square that radius there. So there's the equation of the circle that was pictured in our graph there. What happens if the center is not at the origin? That's where it gets a little bit more fancy. So let's try that. here to get organized. All right, let's draw another circle here. All right, here's another circle. Its center is now located right here at the coordinate 2, 3. So again, anytime you're writing equations of circles, always find that center coordinate if it's a graph first and write the information. So the center is at 2, 3. Let's find our radius. Well, since it's graphed, we can always count it. 1, 2, 3. Radius of 3. So r equals 3. I would also suggest rewriting your formula. Oftentimes, rewriting a formula before you get started will help you memorize the formula. So the more you write this formula, the more you will remember its form. Now just fill in all the information we have. Remember, this is h, this is k. So we have x minus 2. That's where that positive 2 looks to be negative right there, but it's always going to be just that value. This sign right here is always going to be part of your equation, so always look at the number and not the sign. And then we got y minus 3 squared, and we're squaring the radius on the other side of the equal sign. And that is the equation of the circle if we simplify our radius. Alright, well let's try and look at it backwards here. If we were just given the equation, what would the center be? So you would look right here, there's our h, and right here is our k. So you can see that you would write it just like that. And then you would have to think about this being r squared, so you would say r squared is 9, and then you would solve for r. So the way to do that is to undo the square. Square roots are how we undo squares, and you get your answer of 3, which matches with our original. Alright, good so far. Well, let's see what happens if we're not looking at a graph and all we're given is an equation. How are you going to find the center and the radius? Well, it's a lot like what we just did here. Let's say you're given this equation. Your job, or the question in the book, may ask you to find the center and the radius given the equation in standard form. Well, what you're going to do is you're going to look right here. You're going to look right here for your h and k. And this is where it tends to get tricky. You'll notice that the sign changed. Rather than it being x minus our h value, it now says x plus something. Well, that's because our h value is actually negative. If you rewrite it in the standard form with x minus your h, then you'll see that that is how we get a plus there. We get the minus minus. Those always cancel and become positives. And so this is really our value of h. So our center so far has a coordinate of -2 for the x value. And let's continue. Let's expand this the same way. In order to get a plus, we need a minus minus. And so that tells us that our k value is now -4. So our center is found at the coordinates -2, -4. And remember that 16 was r squared. So if r squared is 16, we want to solve for r. So we square root both sides. We get our radius of 4. So here's our answer. Given that equation, we were able to find the center of the circle, the coordinates of the center, and the value of the radius, or the size or length of the radius. Alright, let's try another one. Alright, again, what you want to do is get it to that original form with x minus h and y minus k. So rewrite it to get that form, and then we notice that our h is now negative, and the y is already in the correct form. It's y minus k. So that right there without the negative, just that number there is our k value. There's h, there's k. So our center, the coordinates of our center are really -3, +1. -3, +1 is the center of our circle. This is r squared is 1. Don't get fooled whenever you see that. Know that the square root of 1 is 1. 1 times 1 is 1, so the square root of 1 is 1. So the radius is still just 1. So don't get fooled by an example like that. Again, using an equation in standard form, we just stated the center and the radius. Well, let's work the other way this time. Given the information, given our center, let's say it's at 1, 2, and we're given a radius value of 5. We need to write the equation in standard form. Again, write the equation so you know what you're looking for. And plug in or substitute the values that we know. Here's our h, here's our k. So we got x minus 1 squared plus y minus 2 squared. And that's going to equal our r squared, which is 5 squared. Just a quick little simplification, and we got the equation of this circle. There it is. Alright, so that is equations of circles in standard form. It doesn't get much trickier than that. Just be careful anytime you see a radius of 1. Square root of 1 is 1. R squared. And don't get fooled anytime you see a positive here. Remember that it's going to be the opposite of whatever it looks like in this form. So good luck writing equations of circles in standard form. In the next video we're going to talk about the general form of a circle.